So hello everyone, today we are taking up one of the important topic, that is interconversion of the functional group, and this is presented by the Bharat Prep. So interconversion of the functional groups means that we are converting one functional group into another functional group by using a stable reagent. And here we take first example, that is basically we are taking the alcohol as a group. So you can convert alcohol to aldehyde first of all by using PCC, that is pyridinium chlorochromate in presence of copper metal. And this is very specifically a special reaction to get only aldehyde and not to acids. But if we want to convert into acids, then we use a strong oxidizant, like we have a potassium dichromate in presence of acid, or in place of potassium dichromate we can use potassium permanganate in presence of acid also. So this is the one of the case. And during this oxidation we cannot stop alcohol at aldehyde level, but final product is formed, that is acid is formed. Apart from acid we get other compounds also. For example, we just heat alcohol at 443 presence of concentrate sulfuric acid, so we have a loss of water, that is called dehydration, and in this case we get alkene. And further, this alcohol can be converted into ester also, which is the, we can say, derivative of the acids, by reaction with acids in presence of concentrate sulfuric acid. Okay, not the least, but alcohols can be converted to alkyl halides. For conversion into alkyl iodide we need to use either Pi3 or we need to use a mixture of the phosphorus plus iodine. In order to get bromide, alkyl bromide, we have to use PBr3. And in order to convert into, we can say, alkyl chloride, we need to treat with PCl5. We can also treat with PCl3 because 3 is also used here. We can also use here SOCl2 to get alkyl chloride. This is the first case. And next is we are taking interconversion of the aldehyde. So aldehyde on reduction gives alcohol. And by the way, aldehydes are reduced by using either sodium borohydride or we can say lithium aluminum hydride. Both are important reducing agents. On the other hand, if we want to oxidize, that is aldehyde into acids, we need again, we can say, potassium dichromate and KMnO4 in a medium acidic one. This aldehyde can be also converted into, we can say, cyanohydrin by reaction with HCN, which is a nucleophilic addition reaction. Okay, then this aldehyde can be converted into oxime by reaction with the ammonium hydroxide, and further it can be converted into 2,4 dinitrophenyl hydrazone by reaction with the 2,4 DNP dinitrophenyl hydrazone. So this is all about this. If we are going to interconvert ketones are basically the group containing carbonyl group along with 2 carbons. So ketones, if we just reduce ketones, it will provide a secondary alcohol. Now let's see the difference. If we have aldehyde, it will get converted into primary alcohol. Okay, and for ketones it is very difficult to oxidize them by using a weak oxidizant. And here if we oxidize, we have a Popp's rule, we have a cleavage of bond that is not shown here, we will show in the next video. And further, same reaction with HCN, the CN nucleophile, we get cyanohydrin. With the ammonium hydroxide we get we can say oxime again here, and with the 2,4 DNP we get again 2,4 DNP hydrazone. So this is the case, and where the reactions are same. So whether it's a aldehyde or ketone, look here, whether it's a aldehyde or ketone, what we have same is that all these three reactions, because these are three reactions, are basically nucleophilic substitution reaction. Next we go with a further conversion of acid group. So acid can be converted into alcohol. How? By means of reduction. And what we use here? We use here lithium aluminum hydride. Remember, we cannot use here sodium borohydride, only we use lithium aluminum hydride. Understand? What if we convert it into other types like esters derivative? to simply react with the alcohol in concentration to 4. If we want to convert into acyl chloride, use SOCl2 or PCl5. If we want to convert into amide, react with ammonia or primary amine, we can say. If we want to convert into nitrile, use anhydrous P2O5 or SOCl2. Both will provide and convert them into, we can say, what RCN. Third is basically your interconversion involving ester group. So esters are the groups which can be converted into what we can say alcohol, again by using lithium aluminum hydride. One of the case important here, it can be converted into acyl chloride by just reacting with SOCl2. It can be converted to amide by reacting with ammonia. It can be converted into sodium salt of carboxylic acid in a basic medium, and if we have an acidic medium, it is further converted into esters. This is called deesterification here. Last but not least, it is interconversion of cyanide group, that is nitrile group. So cyanide can be converted into acids by using what we can say acidic hydrolysis, and salts by using, we can say, sodium hydrolysis. This reaction is similar to that of the ester group. Then on reduction, it will provide us primary amine and reduced by lithium aluminum hydride again, which is important reducing agent. But if we want to have a partial reduction and convert into aldehyde, we can use diol, that is diisobutyl aluminum hydride, which is used as a 1 equivalent. And with Grignard agent, it first form imine magnesium salt, which on hydrolysis gives again aldehyde. So remember, these all are important reactions of interconversion functional groups, and the most important is that all the reagents are given here. They are very important. Thank you so much for watching this video.